Hello everybody, I'm going to solve a problem called smallest string with given numeric value. It's the lead code problem 1663. So let's understand the problem first. The problem reads as the numeric value of a lowercase character is defined as its position 1 indexed in the alphabet. So the numeric value of A is 1 and the numeric value of B is 2. So for example, if A is 1, B is 2, then the numeric value of a string, let's say A, B, E is equals to 1 plus 2 plus 5 is equals to 8, right? So given that, given a number n equals to, let's say 3, and a k is equals to, let's say 27, for example, return the lexicographically smallest string which has this value, right? So for example, provided, like, let's say n equals to 3 and k equals to 8, we can have multiple strings that sum up to this. For example, A, B, E is one solution where the value of A is 1, the value of B is 2, the value of E is 5, so the sum of these 3 is equals to 8. Or there can be another solution called A, F, where A is 1, and F is 6, so 6, 7, 8. This is also another solution. Another solution can be A, C, D, where this is 1, this is 3, and this is 4, 4, 5, 6, 7, 8, right? So all of these are valid solutions, but which one is the lexicographically smallest solution? This one, because in the dictionary this will come first. A comes first compared to B or C, right? So given a value of n and the value of k, we have to find the lexicographically smallest string that has the value, corresponding value as k. So let's jump into the solution. So as we observed here, so for a string to be lexicographically smallest, all the characters on this side needs to be smaller and all the characters on this side needs to be larger, right? So for example, comparing these two strings, A is equal, B is smaller than C, so lexicographically this string is smaller than this string, right? But this string is smaller than both of them because it has two A's, which is, this A is lexicographically smaller than C or D. So to generate a string of 3 digits or n digits and provide the value k, what we need to do is we need to try to maximize the value of the least significant digit. So this is the least significant digit and this is the most significant digit. We need to try to maximize the value of the least significant digit, which will automatically minimize the value of the most significant digits, right? So how do we do that? So further analysis, let's say the same example, n equals to 3 and k equals to 8. What we observe is that the minimum value of the string would be AAA, which is 3, right? So which is equal to n. And the maximum value can be G, which is 3 into 26, right? So our solution will always be somewhere in between these two, okay? So now what determines how much maximum value of the character we can put in the lowest significant digit, right? So that is determined by k. For so since k is 8, we cannot put the g here because the g alone has a value of 26, which will be much higher than k. So we cannot decrease the value while putting anything here, right? So if we start with this particular array, where the value is a, and a, how much we can increase this value depends on, so let's say our value is n, right? So we start with a value of n, right? So when n plus, so n is already 1, so maximum we can add is 25, is less than k, that means we can put a G on this place, and still we will be able to fit a solution where the remaining characters will sum up to k minus 26, right? If it is equals to less than or equals to, we can put 26 in that place. But if it is greater than n plus 25 is greater than k, means we cannot put G in this particular position, because the overall value of the string is much higher than what we wanted it to be, right? We wanted it to be k, but it is much higher than k, so we cannot put it there. So we can approach this solution that way. I mean, there are many ways we can do that. The next solution also is pretty similar. So if we analyze the situation, let's say another way of doing the same thing is, let's start with an empty array of n elements, right? So we will try to fill maximum value in this position, and then try to fill the maximum value in this position. So if you think about it, we have only k values to be filled, right? Suppose this is n minus 1, right? So n minus 1, if we put just a, which is value is a, this much, right? If you just put a here, the value would be this much, right? So the remaining value over here would be k minus n minus 1, right? So if this value is greater than or equals to 26, that means we can put a G here, right? If you think about it, if it is greater than or equals to 26, we can put a G here, and then for the remaining places we can continue where n equals to original n minus 1 and k is equals to 26, right? And then we can similarly go on finding the values here as well. So this is another way of solving the problem, and this is the first way of solving the problem. Let's start with the first way. Let's see it in action in the code. So as you can see, I have already written the solution. If you go on the solution, we just created an array of characters with the same value as n, I mean the length is n, and then filled it with a, right? So this now represents the minimum value that this string with n different characters can represent. Now start with the value n, which is the minimum value that it's representing right now, and then we are going to start modifying the last index of that array, and we're trying to maximize it as much as possible. So we'll see a minimum value plus if we add 25, which will make that character is G, right? So if it is less than k, we can easily replace the a with G for that particular least significant digit, right? And then the value will increase by 25. And then if it is equals to k, that means we'll do the same, but after that we can just break out of the loop because we already achieved our solution. If it is less than k, then we can just increase it by this much, and anything before that value, which any digit which is like more significant than this particular index will still be a, and we can easily break out of this loop, and we can simply return the string representation of that array. So if we run this, it's correct, and if we submit it, it's accepted with 98% faster than the solutions. Okay, thank you guys for watching this video. Hope you guys enjoyed it and hope you guys learned something. See you guys in the next video.